In today's note, we're going to be continuing to look at linear and nonlinear relationships, and we're going to again add some more terminology and some more tools to help kind of identify these relationships. So, looking at these these six tables, what we want to do is try to identify which ones represent linear and which ones represent nonlinear relationships. So, looking at all of them, what we should find is that we have the first one looking at the hot air balloon is linear. The second one about a ball being thrown is nonlinear. The one regarding Chester's pay is linear. The Ferris wheel ride is nonlinear. The one with the bacteria is nonlinear. And the one regarding Josh's total savings is linear. So how could we tell by looking at them that one is linear and one is nonlinear? Well, what we talked about in class, and if you look at some of them, linear has a pattern. Now that's not to say that the other ones don't have a pattern, so I'm going to add a key terminology. The linear ones have a pattern that is constant. So that's the key thing here. They have to have a constant pattern or something that remains constant. And to get more technical, what we're looking at is first differences. So if we look at first differences, what they are is subtracting successive y values, y2 minus y1, and I'll get into that in our example of what that refers to. So we're subtracting y values when the x values are increasing at equal increments. So if I look at my table here, I see that my x values are all increasing by 1, and now I want to subtract the y values. And what I had meant by successive means the bottom minus the top. So let's add that here, bottom minus top. So 3 minus 1 is going to be my first difference. So 3 minus 1 equals 2. 5 minus 3 equals 2. 7 minus 5 equals 2. And as I go down, again, it's always the bottom one minus the top one. 9 minus 7 equals 2. 11 minus 9 equals 2. So in my third column here, the two values, 2, 2, 2, 2, 2, those are all considered the first differences. And the pattern here, or the rule, is that if the first differences are all the same, then the relationship is linear. If the first differences are not the same, then the relationship is considered nonlinear. And you'll get into second differences and so on in grade 10 and grade 11. So we're not going to touch too much on the other ones as long as we focus on first differences to recognize linear and nonlinear. So what we're going to do now is just a couple examples is to determine if the relationships given are linear or nonlinear. So for A, again, I want to find my first differences. So that means the bottom minus the top. So -1 minus -3 equals 2. Next one, 1 minus -1 equals 2. And lastly, 3 minus 1 equals 2. So because all the first differences are all the same, so first differences are all the same, therefore it is considered linear. In example B, -1 minus -4 equals 3. The next one, 3 minus -1 is 4. And lastly, 8 minus 3 is 5. So we could say that the first differences are not the same. So therefore it is nonlinear. For example C, what we're looking for now is which of the following data show a nonlinear relationship. So you can look through and you may be able to pick it out, or it may not be clear which one is nonlinear. And what you can do then is go through and check the first differences for each one. So if you go through the first one, 5 minus 8 is -3, and go to the next one, 2 minus 5, sorry, is -3, -1 minus 2, -3. So this one is linear. So that means it is not the right answer. B, again, we can look at, if we go through, 4 minus 3.25, 0.75, 4.75 minus 4, again, 0.75, and again, it's the same thing on the next one. So here, again, B is not a nonlinear. It is linear, so that is not the right answer. C, if we go through and do the same thing again, we get 1/3 as our first difference, 1/3 again, and 1/3 again. So again, looking at our first differences, they're all the same. It means it's linear, which is not the right answer. Now, process of elimination, that leaves us with D as our right answer. If we wanted to prove that, again, we can find our first differences. So 16 minus 25 equals -9. 9 minus 16 equals -7. And 4 minus 9 equals -5. So all the first differences are not the same, so it is non-linear. So again, from this note, the key things that we should take away is the idea of checking to see if it's linear or non-linear using first differences. And first differences, again, are when you subtract the successive y values or bottom minus the top. If they're all the same, it's linear. If they're all different, it's non-linear.